Hello, SCC TechCon 2021 attendees. My name is Pavel Shapotkin. I'm product manager at Izovac. We would like to introduce our product line LUCH, and here we are with our presentation. Our name session is Conveyor Imprints Cleaning, Surface Etching and Activation, all-in-one scalable solution based on ion source LUCH from Izovac. Izovac headquartered in Minsk, Belarus, Eastern Europe. Our facilities include R&D center, production of coatings, design center, manufacturing of equipment, and service center. Our partners located in East Asia, Taiwan, in Taoyuan City. There are marketing and sales team for Asia market, manufacturing of parts, service center also for Asia market. Izovac was founded in 1992, has more than 30 years history, and nowadays more than 350 units of vacuum coaters delivered to customers. I worked at Izovac over 20 years, specialized in ion sputtering, ion assisted deposition, ion treatment, magnetron sputtering. My area of knowledges are PVD and CVD coatings, R&D planning and implementation, finite elements modeling, ion sources and magnetrons design, project management, process management, production management, and product management. We are a customer-oriented company. Technological complaints of our customers is our complaints. The following complaints we would like to introduce our personal solutions for your application, and here they are presented in a table. Poor adhesion of the functional layer to the substrate. There are no requirements for radiation exposure to the substrate. In this case, the solution will be surface ion activation. For etching purpose, where superior surface roughness is required, and it is not achieved by chemical or mechanical polishing methods, surface ion polishing will be a solution. In photolithography, element size less than 0.2 microns, height to width step ratio more than 30 are not available. Etching wedge prevents vertical walls. In this case, precise ion etching will be as a solution from Izovac. Inclined orientation of surface roughness is required. In this case, inclined ion etching will be a solution. Porous deposition films, low laser damage resistance, difficulties in obtaining films with multi-component materials and chemical compounds such as ceramic, ferromagnetic, refractory, and non-conductive complex compositions. High energy ion source sputtering will be a solution. The next complaint, where anti-reflecting coating is required in infrared spectrum with wear-resistant properties at the same time. Optical DLC direct deposition will be a solution here. Ion beam source is intended for substrate precleaning and surface activation to achieve better adhesion of the following condensed thin film layers. The source could be also used for substrate surface etching, straightening, and any material sputtering not limited to ceramic and magnetic ones. Ion beam treatment of the surface defined as a certain effect resulting from applying ion beams of a certain character with defined energy and ions density to the target object. Ions of the working gas are generated within crossed electrical and magnetic fields, and their acceleration and energy are resulting from the difference of potentials within anode cathode. Ions resulting from the working gas ionization, together with drifting electrons within closed magnetic field, create an anode layer. Devices comprise such physical principles are called anode layer accelerators. Here a small cross-section of our ion source LUCH represented in the picture, and we can see the main parameters of this source such as ion beam density, ion beam energy, and substrate speed. The main solution for surface activation will be applying our ion source LUCH. Plasma activation can be performed using various gases. Most of these gases are used to increase the energy of the surface material. The most common way to calculate the surface free energy is through contact angle or wetting angle. The smaller wetting angle is measured, the higher surface energy is obtained after activation process. The wetting angle before activation and after activation. The condition of experiments are as follows. The substrate was being moved across linear ion source LUCH on the distance of about 10 centimeters. Ion current linear density and substrate transportation speed are formed bases for ion's dose calculation. The data are represented in a table below. Oxygen was used as a main gas. Soda lime glass was as a substrate. Here is a dose, ions receiving on a substrate, mean ions energy, electron volts, operation pressure. Contact angle before treatment was more than 35 degrees. After activation, it was decreased less than 9 degrees. As smaller as 10-degree contact angle is acceptable for most applications of coatings on glass. But this result could be much improved by increasing ions energy and dose. Less than 5-degree contact angle could be obtained as well. Regarding IBS quantity to be used, it is dependent on many factors, such as substrate type and its conditions before treatment, conveyor speed, but for most applications with substrate speed up to 1 meter per minute, 1 or 2 ion beam sources are required for activation purpose. Conveyor transportation system is widely used in a mass production. Glass surface during transportation in production process to be touched by conveyor manipulators, rollers, suction cups, etc. Conveyor imprints are appeared on a substrate before deposition, what leads to production defects in the following functional layers and finally leads to product defects and company loss. Here are some photos of imprints represented, like roller imprints and suction cap imprints. We deal with them furthermore. Condition of the test. The substrate was being moved across linear ion source LUCH on the distance of about 10 cm. Ion current linear density and substrate speed form basis for ion dose calculation. Method of calculation ion dose will be presented below. The test conditions are represented in a table. Main gas is oxygen. Soda lime was as a substrate. Dose is indicated in here. Mean ion energy and operation pressure. What is the result? Take a look at the pictures before and after. You can see after the treatment the glass appears transparent and there are no imprints on the surface. Conveyor imprints cleaning is depending on material of rollers, grippers and suction cups to be used. The maximum energy and ion current must be used to shorten time of necessary ion dose achievement. Regarding ion beam source quantity to be used for conveyor imprints cleaning, in our case with substrate speed 1 meter per minute, 4 ion beam sources LUCH are required. Another application for ion beam source is etching. Thin aluminum foil is widely used in electrolytic capacitor mass production. Roll-to-roll coaters with foil widths more than 1 meter are put into service. Capacitor performance is directly proportional to the capacitor electrode foil surface area and its properties. Replacing thin oxide layer to different functional layers, electrostatic capacitance and bending strengths are dramatically improved. Conditions are the same. Substrate was being moved across linear ion source on the distance of about 10 cm. Ion current, linear density, and transportation speed formed basis for ion dose calculation. The test conditions are represented in a table below. Argon as a main gas was used. Substrate, thin aluminum foil. Etching layer is aluminum oxide. Dose calculation value is indicated: mean ions energy, operation pressure, and etching rate. When you compare etching rate with ion dose, you can find a suitable solution for your application with different material when you know sputtering coefficient of your material. Oxide layer etching time is dependent on thickness and foil moving speed across ion source to be used during the process. The maximum allowable energy and ions current could be limited by thin foil possible overheating. Regarding IBS quantity to be used for oxide layer, removing from aluminum foil in our case with substrate speed 1 meter per minute, 1 ion source LUCH is required. The solution for your application is right here. You cannot see it, but it exists. How well ion beam source LUCH fit your technology? That's the question for our potential customer. We welcome you on board of Izovac, and let's design the solution in 7 simple steps. Step 1. Define substrate moving speed and treatment zone. Step 2. Choose desirable ion beam current and energy. Step 3. Define ion source characteristics. Step 4. Calculate high vacuum pump speed and compare with existing pump speed in your equipment. Step 5. Calculate ion dose. Step 6. Compare estimated result with doses given in our review. Step 7. Correct and act again beginning from step 1 if you need to improve the result. Ion current and energy definition is a quite important issue during the solution design. There are 2 graphs in help you to do it. One graph represents specific anode current dependence on specific flow rate. Another graph represents dependence of ion energy and ion flux density. When we're talking about mean energy, we're talking about peak energy, and more than 68% of all ions are in this region. And this inclined angle will be plus minus 15 degrees. Characteristics of ion beam source LUCH are calculated in this table, and this is obvious to talk about it. You just follow line by line and calculate all the parameters for ions for your ion source and exactly for your application. There are some formulas represented for high vacuum pump speed calculation and ion dose calculation. Here is a calculation example represented, just help you to make sure that all calculations are right. The technology and scalable equipment are represented as a complete solution for ion etching of large-scale substrate in the mass production of electronic, automotive, architectural, and defense industries. The aspects of removing such defects as conveyor imprints, oxide films, residues of adsorbed water and gases are considered. The principle of designing a ready-made solution for any applications is shown. Thank you for your attention. I hope our review was helpful for you. Please contact us by email, WhatsApp, and phone. Wish you good luck and thank you.